Hi, my name is Gabe Zika, and I'm presenting my project for EE309 Junior Lab 2. This is a PCB design project. Our project is a step function based on grid frequency. My project team was myself, David Carlisle, and Ryan Downey. The original intent of the project was to create a circuit board to display the power grid frequency. The design would use the grid to power a circuit and supply the nominal 60 Hz frequency for analysis. While power grid frequency is held within a very close band to 60 Hz, daily and hourly variations are detectable as loads are added or removed from the grid. The design was intended to use a timer input into a microcontroller, determine the frequency, and output the frequency onto a display. The project copied the microchip PICM2 Plus schematic for the display use. Unfortunately, we were unable to make the display work for even the simplest commands. Therefore, the group focused on developing this step function that would essentially be needed as the input to a microcontroller if this project was intended to be investigated further. This step function is made by using an operational amplifier with open loop gain to create a plus minus 5 volt square wave. Then the square wave is applied to the base of a transistor used as a switch. The resultant circuit created a very nice 0 to 5 volt step function. A printed circuit board with this design was made for the project. So I'm going to start here by showing you the schematic, if I can find it. This was what we began our project design with. This is the whole circuit. The power comes in here. There's a small transformer, rectifier, voltage regulators, some capacitors to smooth out the signal, and the op amp. Here's our transistor, and this is our microcontroller. Now all this was supposed to basically be set up to read the zeros on the square wave coming off the transistor and op amp, and then display the frequency of those zeros based on some programming that we did. But this is the piece of the circuit that wasn't functioning, and we were kind of running out of time, so we decided to just stop and try to get the step function to work. And we were able to do that pretty well. This was our original test circuit. We built this on breadboard, obviously, and this is pretty straightforward. Here I'll bring up the multi-sim design that we were used for testing. 120 volt RMS, feeding a transformer, so a rectifier. Same basic circuit that we saw on the breadboard. I'll simulate this now, and we can see what happens. So we get a decent step function. This simulation isn't actually as good of a square wave as we got from the actual circuit shown on that breadboard, and that's all part of the report that's gonna accompany this video presentation. But you can see that the square wave, the zero would be pretty low, but we could still get a pretty good frequency out of it. Next I'll show you the Ultiboard piece of this project. So obviously we took our multi-sim design and dumped it into Ultiboard, and I was able to actually cram three versions of this same circuit onto one chip. This particular piece is our transformer, and this transformer wasn't part of the multi-sim or Ultiboard component database, so I actually had to make this. Not a big deal. Then we routed all the wiring to all the particular components, and the resultant circuit looked something like this. So this is a 3D model, obviously, representing the circuit as designed. I hope the video plays this decently and you can see kind of how everything was wired and all the different components. Actually, this is pretty slick. This Ultiboard software makes it really simple to put one of these PCBs together and make it work. So that's that. So I'll jump into the project report here, and I'll talk a little bit more about how the circuit worked on the breadboard. This shows all the different components and yada yada yada. op amp. This is what we were just kind of looking at. It's a screenshot of the Alti board. So this is what the circuit actually outputs, this nice square wave. So it worked pretty well. It was slightly frustrating because we wanted to do kind of an ambitious project, and it got kind of late into the month of June, and then it actually got into July, and we hadn't even started our Alti board piece of this yet, and we weren't actually able to get this printed and delivered back to us in time for this deadline, which is, it's unfortunate, but we know that the circuit works based on the breadboard, and we were able to lay this out pretty easily on the PCB board. So I imagine getting this soldered, it would work just like it does on the breadboard, and we'll just have to hope that this comes in at some point here and we can maybe update this video. But without further ado, that's basically our project. I appreciate the time, and I hope that it was interesting. Thanks.